My dear students, other viewers and listeners, I, Professor Manohar Lal, Director, School of Computer and Information Sciences, welcome you to this lecture on knowledge representation part 1 and part 2. In part 1, we will be discussing mainly representation through symbolic logic. But before that, friends, we will discuss a number of important issues about knowledge. First of all, why knowledge at all? Secondly, what is knowledge? Third, what are the various representations for representing knowledge? Then next issue is about organizing knowledge, how we manipulate knowledge, etc., etc. So friends, first of all, let us take why we require knowledge at all. So for this purpose, you need not look at the slide. For this purpose, first of all, let us go. What is the purpose behind any academic discipline? Almost all academic disciplines are meant to solve human problems. The problems may be of survival in the hostile environment, or maybe just out of curiosity. These may be intellectual problems. So friends, for example, physics deals with the problems of the physical environment around it. Similarly, computer science mainly deals with solving problems using machine as a tool. And friends, we know that main tool for solving problems through computers is algorithmic. Algorithmic means that most of the problems are envisaged to be solved through a step-by-step method having some special conditions. However, even during 1930 and 1940, when there was no electronic computer at all, it was already established that not all problems, rather a very small fraction of the problems which we human beings will encounter will be solvable through algorithmic means. Then what is the alternative? Ultimately we have to solve problems. And computer is a very useful tool in order to solve problems. It is a great aid. So the next was, it was discovered that instead of attempting to solve problems in general, let us restrict to only problems in a particular domain. For example, if there are problems of students, etc., instead of considering the problems in general, we will consider only the environment of a university or of a school, etc. And if we restrict and then we collect the information, how the education is delivered, how the interrelations between various entities are established, etc., then in that case the problem may become more easily solvable as compared to when we don't have knowledge at all. So in summary, it was found for difficult problems which are generally either not solvable or are solvable but taking lot of time, it is better to find out the knowledge of the domain under consideration, and then using that knowledge we will be able to solve problems more easily. I again emphasize, exploitation of the knowledge of the domain under consideration of the problem is going to facilitate in solving problems. So that is the reason why we discuss knowledge at all. And artificial intelligence is one of the branches of computer science where there is emphasis on exploiting the knowledge of the domain under consideration for solving problems. One way of saying what is artificial intelligence is that AI is the set of skill, tricks or methodologies by which non-polynomial time-taking problems may be solved in polynomial time, provided the knowledge of the domain under consideration is exploited. So friends, it is no exaggeration that we need intelligent methods to solve problems, but for intelligence, knowledge is fodder. That is, until unless there is knowledge about the domain under consideration, it may not be able to behave or act in an intelligent fashion. So that is the rationale behind the use of knowledge of a particular domain under consideration for solving problems. Then what is knowledge? First of all, I discussed the issue of why knowledge, and I told you that knowledge helps us in solving difficult problems more easily as compared to when we don't have any knowledge of the domain under consideration. Next, what is knowledge? Of course, we have some vague idea that knowledge should be something like this, but because we are working in a formal discipline like computer science and particularly in artificial intelligence, we must also try to subscribe the definition through some informal or semi-formal or formal definitions. So friends, for this purpose, I request you to look at the slide. Along the slide we say knowledge consists of all the concepts like motion, like friction, like number, like human beings, etc. So all the concepts are part of knowledge. Definitions, whatever we formally define, notations, facts, rules, principle, formulae of mathematics or formulae in physics, relationship between various entities, the tables which are used to give, say for example, the salary of employees, the statistics gathered about the various aspects, say for example the level of education in a particular district, etc., or in the various districts of India. Heuristics. Heuristics, as we'll see later on, are actually the thumb rules which help us in solving problems, though they may not be fundamentally available, but they are generally helpful. Then the plans whichever we construct to do, for example, if we are to do a particular examination, for that we make preparations, but before making preparations, we plan it out. Similarly, the procedures, description, and all that which may help in solving problems. Please see to it, and all that which may help in solving problems can be categorized under knowledge. Then there is another way of looking at knowledge. This was one way. We enumerated a number of things. Rather, anything which we feel, which we can conceive, which we can think of, which can help us in solving problems, may be dubbed as knowledge. There is another way. Another way is that there is you have belief, you have hypothesis, and then the third is degree. Belief means we feel. At one time we felt that the earth is the center of the universe. It was a belief, and at that time it was a sort of knowledge also, because everything appeared to be revolving around earth. There was some sort of justification, but later on investigations told us that no, the earth is not the center of the universe. Then that belief that the center of the universe is earth no more remained knowledge. So knowledge is a relative thing vis-a-vis belief and hypothesis. Belief is something for which there is some sort of justification for us. Oh, it can be also true, may be true. And whatever we think that may be true is called as a belief. Then there is hypothesis. Hypothesis means there is some justification in believing that something. Beliefs may be about yeti, beliefs may be something which is impossible in the real world. However, a hypothesis is something for which there must be some justification. For example, at one time earth was thought of as to be flat. There was some justification. However, later on we came to know, no, the earth is not flat, but it is round. But it could have been a hypothesis at one time, because when we moved, because of its diameter or radius being very, very large, we were not able to see the curvature in the earth around us, and we thought that the earth is flat. So there was some justification in believing that the earth was flat, and because of that you could call it a hypothesis, particularly at that particular time. And the knowledge, so belief, then the next is specialized beliefs are called hypothesis, and still more specialized hypotheses are called knowledge. So what is knowledge? For which true justified belief. That is, we are able to establish the truth also, then and only then we can say that it is knowledge. For example, we have proof that earth rotates around the sun, and therefore it can be taken as a piece of knowledge because it has been truly, it is already established through scientific means that earth revolves around the sun and makes one complete round in 365 days plus some hours, etc. So now this can be taken as a knowledge. But again I warn you that knowledge is not something absolute, that is once a piece of knowledge is a piece of knowledge forever. No, it's not like that. Knowledge keeps upgrading, changing with the new and new discoveries, but still whatever is established at a particular time, at that particular time, that piece of information may be taken as knowledge. There is a third way of describing knowledge. Friends, we know data, then there is information, and then there is knowledge. That is the third way of describing knowledge, thinking of knowledge. What is this? That is, generally we say that data is something which is collected or which is not arranged or which is unprocessed. Then after processing we get information. However, what is the difference between information and knowledge is that whatever information becomes useful in solving a particular problem, in that case, that information becomes knowledge. You have got a particular problem, and in solving that problem, you have particular information. For example, you have a quadratic equation before you, and if you have the method of finding out the roots of a quadratic equation, then at that particular time, particularly for that particular problem, the method of finding out the roots of a quadratic equation become knowledge. That is, that can be used in order to find out the roots of the given quadratic equation, provided the problem under consideration is that of finding out the roots of a given quadratic equation. So friends, what is major difference in one way of describing the major difference between information and knowledge is that knowledge is some information which can be used in a particular problem's solution. So with this rough idea of knowledge from three different angles, one is that whatever is there which we can think of and can be useful in solving problems like concepts, definitions, notations, facts, procedures, rules, etc. Everything taken together can be thought of as knowledge. The other way was that in terms of extension of belief and hypothesis. And the third was that how we extend or how we specialize knowledge from information and data. So friends, this way I have told you a rough idea, I have given a rough idea about what is knowledge. First we discussed why knowledge, then we discussed what is knowledge. Now what are the issues about knowledge when you are going to use it in solving problems? So friends, there are a number of very important issues about knowledge, because when knowledge is in our minds, we need not worry about these. But when you are solving a problem using a computer system, you must take into consideration all these facts, because ultimately the knowledge has to be embedded in the machine in a particular format so that it can be used in solving problems. But the very first thing is how to collect knowledge. The very first important issue about knowledge is acquisition. Please look at the slides. The slide says that the major issues in respect of knowledge are acquisition, then representation. That is, representation you may take is something like that. That it may be you are writing something in English or in say French or in Hindi or etc. So representation may mean how you represent the knowledge, what notation you are using, whether your alphabet set is A, B, C, D, or whether your alphabet set is K, 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 then how these letters of the alphabet are combined to make words, how from the words you make expressions, how from the expressions you make statements or sentences, and from these sentences or statements, how do you make paragraphs, chapters, books, etc. So representation is basically the alphabet set, underlying alphabet set, and rules of combining them in making more complex entities of the language under consideration. Organization is something different. Organization is something like that when you have already chosen English as your language of representation, then in that case, how the subject matter, for example, composition of atom may be the subject under consideration, then how you pen down your ideas, how you construct the whole idea fundamentally at the level of sentences, and then how the sentences are combined together in paragraphs and so on and so forth, and ultimately into chapters, etc. So whenever there is a topic, the topic, first of all, for that you choose a particular language that is called the language of representation, and then organization is something different. You will collect all the connected ideas in one paragraph, then all the connected paragraphs represent one larger idea, and so on and so forth. So organization is concerned about such issues. Then manipulation. Friends, ultimately, as I'll show some examples below, whatever knowledge is there, it is generally not useful directly. Rather, it has to be used through some indirect mechanisms of manipulation, etc. For example, there is a problem whether I should take an umbrella or not, and we are given, if it is raining, then I should take umbrella. And number two, I am also given by looking outside the windows that it is actually raining. And from these two facts we conclude I should take umbrella. Now, how these two knowledge pieces, that if it is raining then I should take umbrella, and number two, it is actually raining, should be combined together, should be manipulated in order to get the conclusion that I should take umbrella. This is a very simple example, and the machine doesn't have that sense which we have. Therefore, how the machine should be made to think in terms of the necessity of taking an umbrella, provided the earlier two statements are given to the machine. Now this is manipulation. That is, instead of the facts which we are useful for us in solving the problem are generally not straight away available to us, rather those have to be figured out from the statements which are already given, and the desired statement is implicitly there. It may not be explicitly over there. This is what is meant by manipulation. And ultimately maintenance. What I mentioned earlier also, that it is, knowledge is something changing. Whatever is fact today may not be fact tomorrow. As I mentioned earlier, at one time, say about 3,000 or 4,000 years ago, it was believed that the earth is the center of the universe. However, later on it came to be known. It became very clear that no, earth is like any other planet, etc. And it not only the sun revolves around the earth, rather it is the other way. The earth is revolving around the sun. So with the passage of time, a number of facts which we thought of as knowledge pieces later on were relegated to just beliefs and wrong beliefs, of course. So maintenance means that whatever today is known in respect of a particular thing or domain, that should be upgraded. Whatever was known till yesterday should and has been modified, then whatever is the modified version of it should be incorporated in the knowledge base, instead of keeping the earlier one which has come to be known as not perfectly correct. So maintenance is also a very important part. Maintenance of knowledge is essential, because if we work with the outdated knowledge, then it will be useless for solving the problem under consideration. So friends, these are major issues in respect of knowledge. That is, first of all, we must acquire and embed in the machine. Then for embedding into the machine, we must use an appropriate representation, and then we must organize the knowledge also. And then we have to manipulate in order to get the desired effects, and finally maintenance is there. Friends, before I go ahead, I'll tell you later on that there are number of representation mechanisms. Now for some time we will be restricting to only representation of knowledge. As we will find out sometime later, there are number of representation mechanisms. For example, proposition and predicate logic is there, then ATN are there, then graphs are there, tables are there. There are so many mechanisms. Which one is more appropriate to the other is a very important question. We cannot use arbitrarily any representational mechanism for any problem. No, it may create problems for us. As is shown on the slide, appropriate representation is very important, otherwise there may be more problems than we have initially with us. Let us take an example. In order to explain what is the role of appropriate representation, friends, for example, the problem under consideration is to multiply 94 by 19. Now in this particular case, one of the possible representations is that 94 and 19 are written in decimal numbers as we usually do nowadays. 9 followed by 4, then cross indicates multiplication sign, then 1 followed by 9 representing 19. This is one way. The other way is that you write it in Roman. And in Roman we know that C indicates 100, and if an X is written to the left, then it represents 90, and the 4 is represented as you can see on the slide, and then 19 is written as the I written between two X's. So my question is, please look, continue looking at the slide. Now I ask you to attempt the multiplication of the two numbers in Roman notation, that is the notation which is given in the last line. You try your best to find out the product of the two numbers 94 and 19, but you are restricted to use only the Roman notation. And I challenge you that you may take hours and hours together, and still you may not be able to find out the product of 94 by 19. So you can see, however, if we write these two numbers in the current decimal number system, then it is just a child's play. Any third or fourth standard student can do this problem just in a fraction of a minute or so. So friends, I just once again emphasize that when you are given a problem to solve and knowledge is to be exploited for solving the problem under consideration, in that case the very first important question for you to discuss, you may not look at the slide, the very first important question for you is the appropriate choice of the representation. And as I'll tell you later on, there are a number of representations which are used for representing knowledge for the purpose of exploiting the knowledge of the domain under consideration in solving problems. Friends, another question arises that of course the natural language, our own Hindi or English, may be used for expressing the problem under consideration, in expressing the solution of the problem under consideration. Is it not possible? The question arises. Because all of us are very well versed in the natural languages, whether it is Hindi or English, etc. Why we have a different language for representing knowledge? Because if it can be done in one of the natural languages, I think it will be the best thing. We need not learn other representational mechanisms in order to represent knowledge, because we are already well versed in the natural languages. Friends, well, natural languages we are well versed. However, there are a number of problems with the natural languages for representing knowledge that is to be used by a computer system, not by human beings. And you know, there are many things which the machines don't have. They can't sense and many other things so far. So in these cases, what type of problems may arise if we use natural language for representing knowledge to solve problems? Please look at the next slide. I take an example. The example is something like that. It is a simple problem from arithmetic. The problem says 4 men and 3 women finish a task in 8 days, and also 2 men and 2 women finish the same task in 12 days. How much time it takes to finish the task for 1 man and 1 woman? Friends, you can see this problem is a quite trivial problem for a 6th or 7th standard student. But it is not a trivial problem if we insist that don't translate it to a mathematical notation. Just you use whatever is written over there, 4 men plus 3 women finish a task in 8 days, and 2 men and 2, just this language is provided for representation of the problem. Just English language is provided to you. And then you try to solve the problem. I think you will find it very difficult to solve the problem. However, if we are allowed to use mathematical notation, then the task may become quite trivial, as you can see from the next slide. Friends, now men have been translated to M. W represents women, D represents day, and plus represents end, A and D. So whatever was given earlier, 4 men and 3 women finish a task in 9 days, 2 men and 2 women finish the same task in 12 days. How much time will be taken to complete the task when only 1 man and 1 woman is allowed to complete the task? Friends, you can see, once the English version is converted to mathematical version, now you can apply your mathematical manipulation rules that multiply this by 2 and cancel one of these, etc., etc. You can see it is a trivial task to solve the problem. However, if we are allowed not to use mathematical notation and only the English version is allowed to be used, in that case you can see very easily, it is almost impossible for us to solve the problem using the English language version only. So again, earlier I explained the appropriate choice of representation through the multiplication of 2 numbers, in which if the numbers are written in Roman notation, then it becomes very difficult to find out the product of 2 numbers. And now I have given you another problem which, when written in English only and not its mathematical version is allowed at all, then again you can see that the problem becomes very difficult to be solved. However, if you are allowed the mathematical version or mathematical representation of the problem under consideration, then it becomes very easy. So, through these 2 examples, I have emphasized the need for a choice of appropriate representation for solving a problem under consideration. Again, I take a logical problem. If I overslept, then I am late. Number 2, I did not oversleep. Therefore, I am not late. It is a fallacious, wrong conclusion which we are drawn. But friends, this wrong conclusion is not in isolation. Many of the people may have a propensity to conclude that if I overslept, then I am late if it is true, and because I did not oversleep, therefore I am not late. It is wrong conclusion. How should we know? Again, if we continue using the natural language, that is, if I overslept, then I am late, and I did not oversleep, therefore I am not late. If only English is allowed to be used in complicated situations, this type of, you may not look at the slide. This type of wrong conclusions may be derived. Please need not look at the slide. This type of wrong conclusions may be possible, particularly when hundreds and hundreds of statements are given to us, and we are required to make conclusions. In those cases, as has happened in this particular case, we have wrongly concluded, because even if I did not oversleep, I may have gone somewhere else and I might have become late. Therefore, saying that because I did not oversleep, therefore I am not late, is wrong. Because of course I got up in time, but then instead of going to the office, I just roamed about different places and did not intend at all to go to the office, and therefore I became late. However, here we are concluding that if I did not oversleep, then I am not late. It is wrong conclusion. But if these statements are written only in English, then it may lead to such wrong conclusions. So in this type of questions, what we generally do, we translate the given English sentences in logical languages. And once it is translated to logical languages allow us not to make wrong conclusions. Not only allow, rather the logical languages help us in seeing the correct reasoning processes. So in this particular case, please look at the slide. We translate into the logical language symbolisms. Here implies, and the squirrel is for not. So overslept means late. Not overslept is given to us. But we know from our logic that if A implies B, then the complement of B implies complement A. Therefore not late implies not overslept. But not overslept, from there we cannot conclude that I am not late. So friends, again I emphasize that our natural language is quite useful for communication purposes. However, to make conclusions, it may not be leading us to the right conclusions. It may lead, of course, but not always. And in many of the problems where numeric languages or logical languages are more helpful, the conclusions drawn only using English or natural language may not be correct ones. So, through this discussion, repeatedly I emphasized that the need for appropriate representation cannot be overemphasized. We must choose in the very beginning what is the appropriate language for us, or what is the appropriate representation for us for the problem under consideration. Again, further I emphasize, for different type of problems, different type of representations will be suitable. One representation may be suitable for one type of problems, but the same representation may not be suitable for another type of problem. So, it requires intelligence, it requires for us to think, ponder over what is the appropriate representation for the problem under consideration. Now, how the knowledge is represented? What are various mechanisms or methods in nature or otherwise of representing knowledge? Mental images of our thoughts. We know that whatever we are thinking, that is, there is some basic unit, say, which are called mental images. Then spoken and written words of some languages, that is also one of the ways of representing knowledge. Then graphic and pictorial. We are given a hilly scene on which some animals are roaming about, etc., etc. Now this pictorial representation tells us about the scene of a particular place. So So this is also knowledge. Then magnetic sports in a computer system, as we all of us know that whatever is knowledge represented in computer system on the disk, etc., magnetic sports may be one of the forms of representation. However, we are mainly considered. So friends, there are various forms of representation of knowledge in nature. It may be in the human mind, it may be on the disks, it may be on a piece of paper in the form of picture, etc. However, in this particular lecture, we will be concentrating only on the textual, graphic or tabular representation. Please look at the slide. Now we discuss some of the well-known knowledge representations used in artificial intelligence. The first is propositional oblique predicate logic. The second is frames. Third is scripts, fourth is production rules, fifth is associated networks or semantic nets, and finally objects. This is not an exhaustive list of the various representations which are used to represent knowledge in artificial intelligence. Friends, in this particular lecture, we may be talking of propositional and predicate logic. However, one thing we must be very clear about, and that is these representational methods are mainly used to represent definite knowledge, unambiguous knowledge, certain knowledge, complete knowledge. However, the world is neither complete, the knowledge of the world is neither complete nor certain. As I mentioned, the knowledge changes, and even some of the statements like Ram is a good person, we don't know how much truth is there, how much goodness is required. Good is not a precise word. So most of our knowledge is neither certain nor precise and neither complete. So in this view, these representational methods which I have enumerated just now may not be enough. So one of the ways of handling one of the deficiencies of the earlier certain, precise, complete world is to handle imprecise knowledge. One of the methods of representing imprecise knowledge is called fuzzy systems. So if time permits, in the second lecture, we may be discussing the fuzzy systems for representing knowledge. Friends, some of the well-known for representing uncertain knowledge. So far I told you that fuzzy systems represent or help us in representing imprecise knowledge. Long, tall, sweet, all these are such words where 1 teaspoon in 1 glass of milk, or 2 teaspoons in 1 glass of milk, or 3 teaspoons in 1 glass of milk, all may be representing something sweet. However, all three are different cases of different degrees of sweetness. So what I mean to say, sweet represents all these. It is not very precise. So fuzzy systems handle with imprecision in our language. Well, imprecision is not a very bad thing. Actually, a large number of concepts may be represented by a single word and can be communicated to others and communicated effectively. That is, whatever we intend to communicate is actually communicated. We need not be very precise. However, there are other blemishes also in the knowledge which we want to represent. For example, uncertain knowledge. Uncertain, for which our belief is. We don't know whether it is true or not. Ram is about 5 feet 8 inch. But we are not very certain. He may be 5 feet 9 inch also, or he may be 5 feet 7 inches also. The knowledge is not certain. There are many other issues of very important significance for us in life, for which we cannot say with certainty. Please try to understand the difference between certain and precise. Precise is when our words are not sufficient to measure it. But the milk is sweet. We can be certain about it. But what is the degree of sweetness is something different. So friends, I tell you, To be precise and to be certain are two different things. Certain means it depends upon the person under consideration whether he knows the fact for sure or not. I hope you understand the difference. So, for representing uncertain knowledge, we have at least three frames of representing uncertain knowledge: modal logic, imperative and deontic logic, belief logic. So, time permits, not today of course, we will be discussing these also sometimes later on. So friends, now we will discuss propositional logic. What is propositional logic? Like any language, it has its alphabet. For example, for representing our ideas in English language, you may not look for the slide for some time. For example, in order to represent our ideas in English language, what do we do? First of all, we have an alphabet set. What is our alphabet set? A, B, C, D up to Z, comma, full stop, etc., the punctuation marks, then the digits 0, 1, 2, 3, 9, and maybe some other symbols. All these symbols taken together constitute the alphabet set of English language. And whatever we want to express are expressed only in terms of these symbols. So, what proposition logic and predicate logic are also two languages to express our ideas. So it must have some alphabet set. So what is the alphabet set of proposition logic, which forms a subset of predicate logic? So first of all, we discuss what is the symbol or alphabet set of proposition logic. And in advance I must tell you that proposition and predicate logic are languages which are mainly designed for making conclusions. As I mentioned earlier also, the natural language is poor substitute. It is poor in respect of drawing perfect conclusions. And in this respect, new languages which are more formal, for which the syntax and semantics is very precisely defined, are designed, out of which those two languages are proposition and predicate logic. But before that, I tell you what is proposition logic about, and then we will be discussing its alphabet set and all that. Proposition logic and predicate logic mainly handle with statements. There is a difference between a statement and a sentence. A sentence may be expressing our ideas in various respects, but statements are specific sentences for which we can say either it is true or it is false. I make it further clear through the following example. For example, snow is white. We can say snow is white or not, either it is true or false. Sun rises in the west. We know it is false. But however, sun rises in the west is a statement, because for this statement, for this sentence, I can say either it is true or it is false. However, go away. Now for this statement, go away, you can't say whether it is true or false. Or please bring me a glass of water. Hurrah, our team has won. The last sentences, 2 or 3 sentences which I have uttered, are only sentences and not statements. Hurrah, we have won that match. It is expressing a feeling. However, I hate losing a match is a statement in the sense I hate losing a match is a statement in the sense you can say whether it is true or false. Some people may not hate losing a match. So in their case it may be false. However, most of the people hate losing match. For them it may be true. So friends, proposition logic and predicate logic mainly handle only statements, that is sentences which are true or false. So friends, we'll continue our discussion in the second half. Thank you.